So there's another function in a common function in our Arduino library called tone, which also generates a square wave, similar to analog write but different. Tone, this function tone, can generate a square wave with an arbitrary frequency. Now this is different than analog write because analog write has a fixed frequency. If you remember, analog write generates a signal, a square wave that's 490 hertz. But tone can change the frequency. And so it can be used for different purposes. Now, tone cannot change the duty cycle, right? With analog write, you specify the duty cycle. Tone has a fixed 50% duty cycle, but tone can change the frequency. So it can be used to make a tone, to make a sound, okay? To drive a speaker or a buzzer or something like that, you can use tone. Now, tone takes either 2 or 3 arguments. The first argument is a pin number, the pin that you want to generate the tone on, that you want to send this square wave to. The second argument is a frequency in hertz that you want for the signal. So whatever frequency you want, you just send that as a second argument. And then the third argument, which is optional, is the duration in milliseconds. So how long do you want that tone to play? That could be your third argument. If you don't have a third argument, it'll just play until you call another function called no tone, which will kill it. Now, we don't want to get to too much digital signal processing and sound and all that, but to say a little bit, we're sending a square wave to make a sound. So tone generates a square wave, right? It has to make a square wave because this is a digital component. It's only zeros and ones. So the wave has to be a square wave. But a square wave generally sounds bad. So when you take a square wave, send it to a speaker, it's going to sound bad. Reason why is because the square wave has lots of basically, it has sharp edges in it, okay? So you've got 0, and then suddenly it's 1. And basically, instantaneously, it's going from 0 to 1. That's infinite frequency if it were to do that. Now, it doesn't quite do that. It's not quite instantaneous, but you get lots of high-frequency components right on those edges where it rises and falls. And those sound bad. They sound like a buzz, like something like that. Where a sine wave, if you would hear that, a sine wave is a pure sine wave. It's one frequency. It's a pure tone. So ooh, something like that. Ooh, that's as close as I can get to a sine wave, okay? A square wave is more, it might be the same frequency, but it sounds like a buzz. It has annoying high frequency components. But that is the best we can do because our Arduino is digital and it's just going to generate square waves. So with digital output, square wave is the best we can do, although sine wave would sound much nicer. And if you really want to do this, if you really want to make music with an Arduino and make it sound pleasing, you would use a shield. We'll talk about that in the next course. We use a shield which has a sine wave generator. Okay, but right now we're talking about square waves. Okay, now for the speaker, we're going to use a piezo element as a buzzer. These are very simple sound-making devices. They look like that. You should have one like this in your kit. And here's its symbol. It's got 2 terminals, right? It's got 2 which are connected to signal and ground. So one side is connected to ground. The other side is connected to the signal, the, say, square wave, for instance, right? And it produces a click, essentially a click, when the rising edge is applied. Or a sound, some kind of sound which we'll call a click when the rising edge is applied. So if you have it clicking at a particular frequency, you can change the tone that's generated. Even though it's still a buzz, you can change the frequency of the tone overall. So driving with a square wave produces some kind of pitch, whatever pitch you want to make. Now here's an example program for making a little piece of music. Now this, when I say piece of music, it's 2 tones. It's really only 2 tones. Now, notice that the setup function, it doesn't do anything. There's nothing that we need in the setup. There's a picture of the connection. So you've got an Arduino, and on pin 8, I'm assuming you've got a piezo element connected on pin 8. One side is connected to the piezo element, one side is connected to pin 8, the other side is connected to the ground. Now, we've got this loop function. Now, the loop calls tone twice. It calls tone, then it calls delay to let it play out for 1 second. Then it calls tone again, and it calls delay to let it play out a second. So this whole loop, all it does is play 2 tones. And since this is in a loop, you would hear these 2 tones over and over and over again. And each tone is 1 second long, because notice my delay is 1 second. And when I make the call to tone, I say tone 8, which is our pin, 988, which is the frequency, 988 hertz, 1000. And then I have a delay 1000, I wait 1000, then the tone cuts off. Then I say tone 8, 1047, 1000, and delay another 1000. So this is just going to play 2 tones 1 second, 1 second at a time, 1 second each tone. Now, it happens at 988 hertz and 1047 hertz. Those are a B and a C on a scale. So it'll just play a B and then a C over and over and over. So, you know, it's a simple system. And if you wire that up, you should be able to hear these two tones. Thank you.